Hello and welcome to our second lesson here in Chapter 4. This second lesson is all about integer exponents. So we talked about in the last one your basics of your exponents, understanding how to evaluate them out as well as write them in exponential form and solve them within some different kind of order of operation problems. Today we're going to be talking about what happens if we have things like negative exponents, as well as what happens when we have 0 as an exponent. We're not necessarily going to worry about this rational exponent, but as you can see, these are the two that we're going to be talking about here today. So first off, our objective for the lesson today is I can learn to simplify expressions with negative exponents and to evaluate the 0 exponent. So first off, talking about our exponents, one diagram they have here, and something that will become a little bit more mainstream when we start talking about scientific notation. So I wanted to bring our attention right to the 0 here, or even the 1 here. Anything to the power of 1 is going to be that value. So if I had 10 to the power of 1, it's just going to be 10. We talked about powers, larger powers. 10 to the power of 2, it means 10 times 10, or 100. If I do something where it's 10 to the 0, it's going to actually just be 1. And from there on, it's like I'm saying I'm dividing by 10. So I'm going to get smaller and smaller. So in this case, when I get negatives, and part of the power that we're going to learn today is those negatives need to go to the bottom. I usually don't keep negative exponents to solve them out. So what I end up doing is taking it to the bottom of a fraction. So to rewrite 10 and negative 1, it's going to be 1/10. Or you can rewrite it as that decimal form. Well then, 10 to the negative 2 is lots like saying 1 out of 10 squared. Well, 10 squared is 100, so you get 1 out of 100, or we can show it in decimal form. And it's going to just continue to get that way as we move forward into our other numbers. So we're going to start with our 10s here. So in this case, I have 10 to the negative 4. So this is a lot like dividing by 10 every single time. Another way we can do it, though, as I started mentioning, is you can take this and make this a positive exponent by bringing it to the bottom of a fraction. So right now, it's a lot like saying 10 to the negative 4 out of 1. So we're just going to flip these around. I'm going to have 1 on the top, and I'm going to bring it down, and I'm going to make it to a positive 4. 1 out of 10 to the 4. That gets rid of that negative exponent, and then I can just solve this out. So really, that's like saying 1 out of 10 times 10 times 10 times 10. And sometimes we're just doing multiples of 10. We only just need to think about how many zeros are going to be in our problem. Since we multiplied it 4 times, that means I'm going to have 4 zeros after that 1. And that's going to be my solution. If I really wanted to, I could put it in decimal form, but I think fraction form keeps it just a little nicer, and we don't have to worry about converting back and forth through those different numbers. So then I'm going to get 10 to the negative 5th. Again, what I'm going to do to make this a positive integer or exponent, I'm going to bring it to the bottom. So I'm going to now make it into 1 out of 10 to the 5th. I'm just flipping it, making it that way. So it's a lot like the same at the top, but this time I'm multiplying it by 5 times. 10 times 10 times 10 times 10 times 10. I hope I did 5 there. I can't remember. So in this case, I'm going to have 1, and then I'm going to have 5 zeros. And that would be my solution for B. A little bit more in depth about this rule. So here's this negative exponent rule. It says any non-zero number raised to a negative power equals 1 divided by that number raised to the opposite, or that positive version of the power. So that's why I was taking things, like 10 to the negative 2, bringing that down to the bottom, or making that exponent now a positive, and I'm going to solve it out this way. So we can do that with things that aren't necessarily to a power of 10. I could do it with 5. 5 to the negative 3, I'm going to change it into equaling 1 out of 5 to the third, and then I just solve it out. 1 says 1, and I just think, okay, 5 times 5 times 5, well, that gives me 125. So let's try it with some of these ones. So this one, I've got a negative 2 to the negative third. Now this one, I can see where we might run into an issue because our base is also negative. Remember, we can solve with a base that's negative, but we do not like negative exponents. So when I rewrite this, I'm going to have it 1 out of, still parentheses, negative 2, and the only thing that's turning to positive right now is that exponent. So when I expand this out and I solve this, I'm going to take negative 2 3 times. Oops, 3 times. I always say that, and then I write the opposite. I'm going to take negative 2 times negative 2 times negative 2. When I do that, negative 2 times negative 2 gives me a positive 4, but positive 4 times a negative 2 gives me a negative 8. So you could write it as positive 1 out of a negative 8, or a lot of times you'll see it as just the whole entire fraction is labeled as negative 1 out of 8. Because remember, a positive divided by a negative just means it's always going to be negative then. Opposite signs make it negative, otherwise same signs make it positive. So I'm going to do the same thing for B here. I'm just going to make sure that I put this 6 at the bottom with the base, and then I'm going to make that exponent a positive. So when I solve this out now, I'm going to have 6 4 times. This is going to be a big number. Okay, 6 times 6 is 36. So I could do 36 times 36 here. Or I can make it a little simpler to me and do 36 times 6 times 6. I'm going to use my crazy lattice way to solve this out, since we are still not using any calculators. Again, feel free to use whatever method you like when multiplying out different types of numbers. I hope I got that all right. Nope, that was 9 here. 8. It looks to be 1,196. Let's just double check here. I know I said no calculators, but for this instructional video, I want to make sure that we got it right. Oh, I forgot the 2. I carried over too many. 2. 1, 2, 9, 6. Nice. And so it would be out of 1, 2, 9, 6. So then, the only other problem that we have to go through is talking about 0 exponents. And I think 0 exponents are actually probably the easiest part of all of exponents. Because if we get to this rule here, you're going to see that it says the 0 power of any number equals 0, except 0 equals 1. So basically what they're saying is that as long as it's to a power, or the base is not 0, it's going to equal 1. I could put 100 and put it to 0. It's going to equal 1. If I'm going to put a negative number and put it to 0, it's going to be 1. I can't really do 0 to 0, though, because you're taking nothing to a certain power. That just doesn't work. I can take negatives, I can take fractions, I can take decimals, I can take large numbers, I can take small numbers. Any of those are going to work, and they're always just going to equal 1. So let's use what we know about our exponents, about, the operations of exponents, negative exponents, as well as 0 exponents, to give ourselves another order of operations problem here. So first off, thinking about my order of operations, or my PEMDAS, my parentheses come first. Looking at my problem, I know it says simplify, and again, that's a weird terminology they use here in exponents. Really, this means to solve. Solve it out. What is this actually going to equal to? So we're going to look at our parentheses first. I notice there's a set of parentheses around this -7, but there's no operation in it. So really, it's not an parentheses operation right now. But I do realize there's a 4 plus a 2 in parentheses. So we are going to do that operation first, and then we can look back at, again, our order of operations. So basically, the 2 is going to stay the same over here. The plus is still going to stay. I'm still going to have this negative 7 to 0. And then I'm going to subtract, and now I'm going to add the 4 plus the 2. I'm going to keep it in that parentheses, though. 6 to the negative 2. Awesome. Now we've gotten rid of that parentheses, and there are still parentheses, but there's no operations within those parentheses. So now I can start tackling my exponents. So looking at my first one, I have negative 7 to the 0. And we just started talking about the fact that anything to 0 is going to be equal to 1. So I'm going to have 2 plus, this is going to cancel out and just equal 1. And then I can figure out what this is, the 6 to the negative 2. So I'm going to make 6 to the negative 2. Remember, that means I am going to put that 6 on the bottom. It's a lot like saying a fraction, and I'm going to have 6 squared on the bottom. So really, when I solve this out, 6 times 6 then gives me 36. So this part turns into this, and so now I'm going to have to subtract 136. Ooh, okay. Let's think of our order of operations again. We did exponents. We don't have multiplication or division. We do have addition and subtraction. We go left to right with those. So I'm going to add these two first. 2 plus 1 is 3. And then I have a subtraction of 136. Now, the value of 3 is 3 whole values. So if I really wanted to, I could turn this to a complete improper fraction. But I also know that 3 is the same as 2 and 36, 36. Because 36, 36 is 1 whole, and here's my other 2 wholes. Add them together, they make 3. So I could set it up like this and then subtract the 136. The whole number still stays as 2. I just take 36 minus 1, which is 35, and the denominator stays the same on the bottom of 36. And that would be my solution for this problem. So at this point, we will get back together here as a group and go through some more problems, and it'll be some work time. So just let me know if you got any questions, and I will see you then.